Hello and welcome to my Lab 1 presentation. Today we'll be talking about charge tapes. This is for Physics 2. So first for the purpose is to create charge tapes and observe how they interact, and then use those interactions to calculate the amount of excess charge on one tape. So first of all, some of the very important equations used, the most important being Coulomb's law, as you'll see on the left, which is K times Q1 times Q2 over R squared. This one's missing the R hat, which is just the direction. But for the later parts of the lab, we'll also use the Newton's second law with gravity forces, the force on an electron, and then also I have K listed, and the number 4 is a much better representation of the left equation. And then conservation of charge, always have to keep conservation. And yeah, let's move on. So first for the procedure, as you're aware, you got to prepare a charged U-tape by firmly pressing it onto a base and tape and ripping off quickly, which will create the charge. Identify the sign of the charged tape by observing how it interacts with your hand, neutral objects, and other U-tape and a negatively charged plastic pin. Measure the distance between two charged U-tapes at the moment they repel each other, strongly enough to create a stable separation. And then finally, model the two charged tapes as point charges to estimate how much the charge is required for one tape to float above the other. And then repeat the charge estimation using a more realistic model that treats each tape as a line distributed charge instead of a single point. So for the experiment, as you'll see on the left, basically you have a charge tape, you hang it from a desk, use your hand to get near the bottom of the tape, and the tape should attract to your hand. And then for the second part, you take a piece of charge tape and you put it under another tape, and it should levitate it slightly. And this is essentially just showing you that there is attraction and repulsion between the two tapes based on the charge. So with your hand, you're expecting it to attract, and with the actual interaction, you know that they're opposite charges, so they will attract. Same thing with the pin. I just took my pin and rubbed it through my hair real quick, and actually did very well. And then with the U-tape, you expect the opposite to happen since they are the same charge, since they both were ripped off quickly. And then, simple conclusion, the tape has a positive charge. And then here, I have demonstrated a few pictures. I couldn't get a whole lot of really good pictures, and I had a decent video. But on the top left, it starts with the two pieces of tape. And then the next picture shows them stacked on top of each other. And then after that, where my finger is, I ripped it off really quickly and then stuck it onto the side of the desk. And then from the next picture, it's a little difficult to see, but it is moved over quite a bit when my finger was pulled close. Now, for the results, I had the estimated charge of 1.962 times 10 to the negative 8th. And the estimated charge I had as 1.81, which were pretty close. So for the point charge model, some of the assumptions are that all charges are located at one point on the tape. Only forces were electrical charge and the gravitational, and they cancel out a certain distance. There's no air resistance, and both pieces of tape have the exact same charge. Here's my glow script code. Nothing that complicated. Nothing really needs to be pointed out. Besides, I had a separation distance of about 0.025 meters. And then, yeah, that was really the only thing significant. And here are my results. As you can see, you have the proper arrows, and then the charge located at the bottom, shown from the code. And I also have the link to it if you would like to see that. And then for the lines of charge model, same assumptions, minus the charge is evenly distributed across the tape. Realistically, it's probably not exactly like that, but it is a good assumption to have. It makes computation a whole lot easier. So with the code, basically, it's a very similar code, just kind of extended out. And here are my results. My arrows looked really weird when I was making this, so I had to do a lot of playing with the arrows. But at the end, I think they look really good. But as you can see, the charges are distributed properly, and then your net is properly oriented. First for some error. When I was messing with the glow script code, I think I might have had a couple places where I was messing with the magnitude of stuff, and I was getting some weird numbers at first. Eventually, I got it to work out, but with some iterations, I was getting crazy numbers, and I'm not really happy with that. but I think I got it figured out. And I couldn't really figure out where my problem was. The second, more obvious, you got non-constant electrical charge between the U tapes. And then third, the pin was not negatively charged or not the same charge. Fourth, for the lines of charge model, the electric charge was not properly distributed or perfectly even. That just kind of makes sense. That's a realistic scenario. We can't really account for that in simple code. Now for the what ifs, the electrons are negatively charged and the protons are positively charged. What if the signs of their charges were reversed? Meaning the electrons were positive and the protons were negative. Nothing would change. They would still repel. It's pretty obvious, I feel like, as you can see on the right. Flipping them doesn't do anything. What would change? What would change with observation about the tapes? The exact same thing would happen. The charge doesn't really matter. As long as they're the same, they will always repel. So for the whys, when we compare the estimated value of the charge you get when you use your experimental data to produce a point charge model, so the first code, to the value you got with the line charge model, the second code, the two computational values for Q will be different. Why are they different, and which value is more likely to be closer? And simply, the line charge will be more accurate because the single point charge is too oversimplified and it's not realistic. Thank you very much for watching. I hope you have a great rest of the day.